Okay, hi. So, we can just go ahead and get started now. Okay, so I have small control. So this is meeting number 19. So, uh, okay, so here we have the disclosure, and then so here's the agenda for today. Basically, as you guys probably read from the email about what this meeting is kind of gonna be about today, it's gonna be a lot more like chill and fun. It's more like we're gonna be playing two kinds of Bitcoin themed games. So the main game will be Privacy Jenga. I have a Jenga set in my backpack right now. So we can play that in a bit, and that's like kind of the main game. But before that, we're gonna be doing a kind of small mining Bitcoin game. The mining Bitcoin is not so much a game, but it's kind of like a small kind of interactive and simplified, fun way to kind of learn about how mining Bitcoin itself works. Because I think the idea of mining Bitcoin is kind of like everyone knows it happens, but the specific details are kind of fuzzy to us, and people don't really truly understand how it works. Um, okay, so yeah. So how exactly does mining Bitcoin work? Again, I'm going to explain it in a very simplified way because the actual process itself is not super complicated. So it can be, um, so anyone can really understand it in a way where, like, regardless of your technical ability, you can know the process of how it works. So I know the club itself does attract and include kind of a lot of different majors, because I guess that's what's so special about Bitcoin called Bitcoin Club. It kind of incorporates, different aspects of like, tech, but also like healthcare and like environment stuff. And so I know, some of the majors include a lot, at least like in this club, like for me specifically, I am CS and computer science, which is a lot more technical, which is kind of why a lot of this presentation is more on the tech side. But I know this club also attracts a good amount of, ILR, Dyson. So if your major itself is not super tech savvy or related to tech, could you just like raise your hand? Oh, okay. Okay, cool. So can you guys just say what are your guys' majors?
MBA. Yeah, an extension of the MBA program.
Oh, really? Okay.
This is Bitcoin Club?
Yeah,
Yeah.
this is.
Go on.
Okay. When you're just joining us, basically today and what we're doing is kind of it's more chill. We're kind of gonna be playing two Bitcoin themed games. The first one is not really a game, it's more like a fun and interactive way to learn about how mining Bitcoin works. And the second one is the actual like game. It's called Privacy Jenga. But we'll do that in just a bit. And then basically I was explaining how a lot of people I was explaining how a lot of the majors that this club attracts aren't, super technical. So I was saying like, if your major isn't really related to tech, like, could you like raise your hand? So yeah, or is your
Yeah.
okay?
I'm a grad student for business analytics.
Okay, yeah, they're also in this.
Yes.
Yeah.
Yeah. 2 years.
Yeah, I'm also in Johnson MSBA.
Lovely.
Like I actually have one of my buddies also in the program is coming.
Okay, cool. Okay, yeah.
Very.
So this presentation, like today, is not super. It's more like tech related. Yeah. So, it's just to get like a little introduction on that. And so, a lot of how the mainstream media articles actually kind of portray Bitcoin mining is actually like they kind of say, or even before I knew a lot about Bitcoin, I also heard this too. A lot of it is they kind of say miners are kind of competing to crack like these crazy like cryptographic puzzles. It's often what I heard a lot before. And I always like got the impression that um like what uh mining is a lot of like solving complicated math problems. But this is actually like false. There's no cryptographic puzzles or like any complicated math problems involved with mining Bitcoin. And yeah. And even like these two photos I have up here, I These two photos are actually like I just went onto Google and I just searched up like mining Bitcoin, and you can see that like these photos themselves, they look very like intimidating, and it seems like this whole very like cryptographic complex system is working, but that's actually not the case. So what mining is mining is just a simple comparison game of two numbers. And you know, comparing two numbers is a very like it's a very easy thing that we all know how to do. Um, like, you know, I think we've all learned how to compare numbers since like we were like 5 or 6. You can easily tell if like a number is like equal or like larger than one another. So we all know how to do it. So like here's a very simple example. We can see which number is smaller. We have 28 versus 32. And like anyone, I'm sure in this room knows that the number 28 is smaller. Uh yeah, so that's like very simple example. And then a slightly harder example is looking at these houses, which are of course, you know, bigger than previous example I just gave. And just by looking at this, well now you guys may have more time to like count the number of digits, but just looking at this itself, it's a bit harder to see or slightly harder to see which number is smaller, right? Because to the naked eye, you can't like easily tell how many digits are. Um, Sure. So, however, if you are able to stack one number on top of the other, it becomes immediately very apparent that the second number is actually smaller than the first one, and it's kind of a because you can tell that you know the second number has less digits compared to the first one. And one nice trick you can kind of do for this is padding out the digits. And what this means is that adding leading zeros in front of each number so that each number has the same number of digits. This is a very like, you know, easy concept to understand. Um, and so it's easy to tell like if a number has more leading zeros or zeros at the front, then that number will always be considerably smaller. Yeah. Okay, so here is a slightly harder example than the last one. So what these numbers are is these are extraordinarily large numbers in a compressed number format. And that's why these numbers have like letters in them. They're still numbers, but they're just extraordinarily large. So to be able to see and read them, we kind of have to put them in this format, and that's why they are in this format. Um, yeah. Okay, but however, as we can see here, the same rule will still apply in that the number with the leading number of zeros is considered the smaller number. So we can tell like the second number is the smaller number. Okay. Um, and then now I'm just going to introduce this other concept called hashing. You guys have probably never heard of this because it seems most of you guys are MBA students. This is a more technical presentation. But basically, to explain it very simply, is hashing is just a mathematical function that takes in something and spits something out. And so it's just an input, and then we have an output. And the input to a hash function can be it can be quite literally anything. So what I mean by this is it can be like any string. It can be like a word, it can be a sentence, it could be a paragraph. Yeah, literally anything. And it doesn't have to be just a string. It can also be like a photo. And it could also like it could be like the entire contents in like your in like a specific folder or even in like your hard drive. So it could be anything. And basically, regardless of whatever input it is, the output will always be of a fixed length. And so you can kind of think of this for a good way to think of what hashing is or a hash function is like a unique identifier or a unique fingerprint of the input or of the data you're inputting in. And so I'll like demo hashing in a bit, but basically the output will always kind of look random. It's not random. And hashing itself is a one-way function. So I have these two analogies here to kind of understand that and explain the concept better. I think the second analogy is a little bit better, but basically the idea is that when you like for falling through a trap door, um, when you fall through a trapdoor, it's very easy to fall in, but it's exceedingly harder to come out of that trapdoor. And another example or analogy for what hashing is that you can make a smoothie with let's say the fruits we have here. We have like bananas, grapes, strawberries, and basically to make a smoothie, we put all these ingredients through a blender. And once you blend it and you make your smoothie. Oh, covering with a smoothie there. Once you have your smoothie, it's impossible to unblend them. So basically, for a hash function, we take these inputs and then you are not able to figure out the input from the output given. Does that make sense? Okay, cool. So actually for Bitcoin itself, what each Bitcoin block does is it uses SHA-256, and SHA just stands for a secure hash algorithm. And this is SHA-256 itself is a very popular type of hash function. And what that 256 means is that each hash itself is 256 bits. Yeah. Okay, so just to understand hashing a little bit more, I'm gonna go to this website to just demo hashing a little bit to understand it. You guys can also head to this link. It's pretty easy to type out. It's just t plus dot plus slash hash. Um, so here it's just a SHA-256 hash generator. Then basically we can input a text to be hashed here. Does anyone have like a word or a sentence or a phrase or anything they want to put in?
Mining.
Okay, cool. Yeah. So we can just put my name and then just to understand like what this is, basically like we have this input as a string. It's just called mining. And then through the SHA-256 algorithm, we created this hash output. And this huge like all these letters and numbers, it just represents a huge number that is 256 bits. And here we can see the output. It looks very random, but it's not actually it's not just completely random itself. There's uh like an algorithm it does to figure out what the result should be. Um and something to note is that like if I were to take this input that we have, writing just like an exclamation mark, we can see that the actual result has completely changed. And this is very like intentional. Just slightly changing the input will dramatically change the output. We can see like getting rid of this and adding this, like the input and output is completely different and all we did was really add like one exclamation mark. Yeah. Okay, so that was just like a little bit to show. You guys can also like go to this link if you want to or like, you know, move through hatching a little bit. Um okay, and then to go back. And then the next thing we have is actually a mining demo. So to go back to Bitcoin mining, uh basically this mining demo, you guys can also go to this link. But basically um what this is gonna kind of show is how the information we just learned for the previous couple slides the previous couple slides kind of ties together. Um, and so basically, as I said before, we can put anything into a hashing function or hashing algorithm. Um, and this includes a Bitcoin block. So here is kind of a very simplified example. And so a block has a header with some metadata. If I click this here, here is like kind of some, quote unquote metadata. And here is kind of like a list of transactions like waiting to be confirmed. So we can see here that there's two different numbers. What is it? So we have so these two different numbers that we're comparing. So we have a uh, difficulty target and a block header hash. So here's the Bitcoin block header. There's the difficulty target, and basically the uh, difficulty target in Bitcoin. Oh, sorry. Yeah. Okay. So the what this difficulty target in Bitcoin means is that this difficulty target in actual real life is kind of set every 10 minutes such that the blocks are bound by this target. So um, basically, this site that we have here is a very glorified version of a mining simulator. Um, and this basically this block header with this metadata also includes, a link to the previous block here. And what this kind of just represents in a glorified way is like a blockchain. And like these are some transactions here which are waiting to be confirmed onto the blockchain. And so what we're going to do is we're going to put this block into, the fruits blender, and we're going to see what the SHA-256 hashing looks like. And so here, I just pressed hash, and we can see that this block header hash that we use is actually not less than the difficulty target here. So if it were less than the difficulty target, then we would have been able to find a block that the Bitcoin blockchain would be confirmed to be immutable. So basically, for example, here, since I hashed this just now, we can see that the block header hash we have, it starts with the letter E, right? But the difficulty target has a leading 0. So that means that it's not less than the hashing that we just did. And so we saw before that any kind of change to the input changes the output dramatically. And so what we can do here is arbitrarily kind of change this block that we have by adding a knots. And then and this would leave the rest of the transaction intact. So adding a random number and so we can add random numbers and hash around and see how the hashing function itself changes. So to demo that, we can kind of give that a try. Does anyone have like a number? It can be any number that wants to input here.
21.
Okay, sure. 21. So I'm just gonna add 21 here. And basically I didn't exactly explain what a nonce was, but a nonce is just it's kind of a random number that can be used once. And yeah. So if we hash it, so block hash with nonce 21, we can see this number or this hashing output is not less than the difficulty target. So does anyone have another number they want to guess and check? 1048. Oh, unfortunately, that does not work. Yeah, so we can like continuously input just, a random number of a random kind of guess and check method. And basically, me inputting all these numbers and by guessing and checking using the hash function is essentially how Bitcoin mining works. So what Bitcoin mining does is it uses this guess and check force process into trying to figure out proper result, which will end up having the final hashing result be less than the difficulty target.
When you say difficulty target, and even though if should I do you want me to should I wait because I have a question about that one? If you're
Oh, no, you can go ahead and
does that relate and maybe so you can kind of well, letting the really might not know this, does that relate to the adjustment that happens for 4 years? Or that this needs something different?
Oh, I'm actually not too sure about that. I know like the difficulty target itself. Oh, perhaps it does relate, but also when mining is happening in like, real oh,
Oh, there we go.
okay. Oh wow, I found it. Nice. I know that in real life when this is a very glorified simulator. In real life, when this happens and we have a difficulty target, the difficulty target is changing every 10 minutes. Ala is raising her hand. Um,
Oh, I was just gonna
yeah.
say if I heard Sal's question right, the difficulty target is what is
Can't hear
being
you.
adjusted. Oh, okay. I'll put it in chat. Sorry. I'll put it in chat.
Oh, okay. Yeah, let me just go back to the Zoom. I don't think I can on here.
No.
Let me disconnect.
She's going to understand it. Got it. Okay.
Oh, okay.
Okay.
Okay,
Awesome.
cool, great. Yeah, so that was kind of a mining demo. So it's kind of like I guess like introductory into how Bitcoin mining really works and like a very easy way to, understand it because a lot of people don't really even understand like they don't really understand the little technical details. Yeah. About Bitcoin mining. But that was kind of the first, like interactive way to understand Bitcoin mining. And then the second part of today's meeting is actually playing a game, Privacy Jenga. So if you guys also want to like understand more about it, I have this link here to learn exactly what how to make your own game or learn like the people behind it. But basically, what Privacy Jenga is, it's a way to it's a way to learn, or it's a fun way to learn the best privacy practices into your usage of Bitcoin. Um, yeah, so that's kind of it for like this slideshow presentation. And then for the rest of the meeting, I have this Jenga set here. So that Ellen mentioned that uh basically the woman who created this privacy Jenga game, she actually had a Jenga set, but that wasn't able to be like delivered to here on time. So basically, in the instructions, actually, in this like Bitcoin Jenga um page, there's actually a way to if you have your own Jenga set, there's a way to manipulate it to kind of create your own version of the game. So I actually I found a Jenga set and we can probably use like that table basically over there because it's kind of in the corner. Um,
Today's a big day for Bitcoin. Huh?
sorry, what?
Today's a really big day for Bitcoin. It's all-time high. Yeah.
Is it? Oh,
Price wise.
wait, I think I
Yeah, it's 75.
oh,
The election.
it is the election.
Yeah. Trump is actually a huge advocate for Bitcoin. Yeah.
Yeah.
He's huge. Yeah. I went to the Bitcoin conference this past summer.
Right. Oh, dude, I saw.
Yeah.
You met that one guy.
Yeah. It's Da Vinci, Jeremy, the sailor.
So
National.
yeah, I kind of had to make sheets or everyone can come up and play. Yeah. I have LinkedIn stuff. Sorry, yeah. So I kind of had to I kind of had to make shifts and basically I like cut out pieces of paper and like stick them. So it's a bit jank, but it'll make do. It'll work for the time that we have. Okay.
So it's like a big friend.
You know what?
You
It's
did.
more like a learning game to kind of learn everything. I guess it'd be better for the chairs. Yeah.
Yeah.
But
Well, that makes spirit.
so
You grad student here as well.
no, I'm not, but I know most of you guys are. Are you guys all grad students?
Very few much. You guys are
Grad
awesome.
student? You're also a grad student?
Nuts.
You all MBA grad students?
We're MSB. We have MBA.
Yeah.
And Milo.
Okay.
Unfortunately.
I'm an undergrad. So no, I know most of you. Yeah, yeah. I know all of you guys are like business. Yeah. But I'm like actually CS. So yeah.
I studied at CS for undergrad.
Oh, really? Okay. Well, that's cool. Yeah.
So do you do a lot of coding and stuff, or?
Yeah.
We're doing Python right now.
Yeah, I think
Really?
already.
Yeah.
But I was list. You're back.
So
You know? Here, like you're melody.
Yeah.
There's listen.
there's also phones and like
You also.
and then like
Somebody's. That's. Yes.
yeah.
And your name. Yeah.
So it's that one takeaways here.
We'll add it to the system in there. That one. We can have it. Hold on.
There's awesome.
Yeah, I know most of you guys are like Dyson, ILR, MBA,
Yeah.
but
I think a bunch of other guys as well from it's not. Yes.
other meetings, there's more. It's like today is just a lot of
Yeah.
today's just a lot of grad students.
Every more folks. When
Yeah.
you're here, everyone. So.
Well, I love Bitcoin. This is like my thing.
These conference ones too.
I went to the Bitcoin magazine one in Nashville this past summer.
Nice.
So Trump spoke there.
Yeah.
He said if I win, he's like, I'll make sure I carry on.
So you saw Trump speaking?
Yeah.
Yeah, I got hit the right. It's fine. So you think selection. I think start the bull run. You know,
It already started.
The problem are.
was it more massively?
Yeah.
So invest now. Right.
Yeah.
You should have.
Invest now.
Invest heavy now.
Definitely.
I've been holding up. We're at
Yeah.
highs, so I just. I honestly.
It's only gonna go up.
Yeah. Next up.
If you're a Republican or a Democrat, I like to make money. So
Starting goes little advice. Starting goes little advice. Anyways, so I have to.
Yeah. So I know today's like meeting was like a lot more technical, but I know other meetings are a lot more like not this technical.
Oh, we'll be here next semester. Every semester, so you guys can just.
Yeah.
That's your. Non-technical people interested in Bitcoin. Kind of manage to deep dive into technical details.
Okay, that's cool.
I feel like, yeah, when you develop interest, it's great to get a better understanding of the technical part.
Yeah. Wait, so this game or everyone can like come wait, it's not like competitive. Basically like how it just works. Oh, it's too. Like,
I
Yeah.
saw them up.
yeah. I was gonna get another Jenga set, but I only got one. Yeah, it's actually not even. It's not like real Jenga. It's like a ring tower. But anyways, basically, just how this works is that all these like Jenga blocks that have like the color red, orange, and like uncolored. Basically, I have these uh,
So does each color mean something?
yeah.
Each level.
Wait, I was like explaining it, but then I forgot like on the website
Oh,
they
that's
have
awesome.
yeah. I did actually,
Oh.
but I cut them out. Basically what it means is that like we have like the different levels have like severe, moderate, and mild. And basically, we just all the blocks that have like that are like all these color coded blocks. They have kind of like different, like they have like information, and basically they kind of explain different. Because the idea of this game is to kind of explain the best way to like manage your Bitcoin usage in the best privacy, like the best ways. And so the idea is just that like as we play this game, the different color coded blocks will like the information on each kind of corresponds to the level of like like this says broadcasting a transaction from your home internet. That's kind of like it's like a mild privacy concern. Yeah. So there's like different privacy concerns correlated to each color versus like how severe you should worry about it or how moderate you should worry about it.
Oh, cool.
Yeah. So it's just like a game that we can kind of play. Yeah. Yeah.
You should like.
Okay. I'm just gonna hold on. Wait. I'm gonna head.
Build it or just take parts out.
It's kind of like the point just to like have fun with the game itself as you have fun with the game. You kind of learn on the different
I don't read on paper. I should worry about
Yeah.
broadcasting.
Okay. I really hope this is. But basically, for example, I just pulled out this block and it says says using an app that allows SMS password retrieval.
That's all right.
Yeah, so that would be because it's like colored orange, it would kind of be like a moderate concern.
Maybe you think that would be a moderate concern, I'm curious.
Because it's possible that because of SMS password retrieval, it's more easier for other, hackers or other users who don't want to access your data.
I love it.
Yeah.
Just want to see if they were home. Yeah.
Okay, yeah. Here. And